Okay, good afternoon, everyone. My name is Roshni Parry, and I lead the worldwide specialist organization for hybrid and edge at AWS. I'm joined today by Umar Chowdhury, PM leader for telco networks, and he will be walking you through telco-specific migration workloads. I'm hoping that all of you were able to get here fine. It took me 40 minutes to come from Venetian, more than 40 minutes. So thank you for making it here. And we'll be talking about migration strategies for workloads that are on-premises or edge-bound. In terms of agenda, I'll quickly walk you through some of the challenges the customers that I talk to have come across with these latency-sensitive workloads that are bound by data residency or even local data processing requirements. Then we'll take a look at how we at AWS are addressing these challenges. Then we'll spend most of our time on the third topic, which is migration strategies with examples from Athena Health and Absa Bank. And Umar will walk you through how we've made significant progress in migrating core telco workloads with an example from Telefonica. And finally, I will wrap up with next steps, and I'm hoping to give you 10 minutes of Q&A time. If you're not able to get to Q&A, please grab me or Umar in the hallway, and we'll be able to answer questions or set up deep dive for your specific use case. All right, so I've been at AWS for 6 years now, and in my last 3 years in the business development role, a lot of the customers that I talk to, they have different drivers for cloud migration, whether that is agility or improving the security posture or improving TCO. Sometimes they just want to do an international expansion or M&A or just adopting new or next generation technology like AI, ML. Whatever the use case is, one key ask that comes across is to be able to build once and deploy anywhere. These are some customers that I work with on a day-to-day basis. And ASU, they've migrated their latency-sensitive application to local zones while keeping their other peripheral application in the region. And they have the exact same requirement to be able to build once and deploy anywhere. FAB, or First Abu Dhabi Bank, they modernized and they migrated their end customer workloads to an outpost-based deployment, eventually looking at the region as the end deployment scenario. Epic, they are hosting their North America Central server for Fortnite on our Dallas local zones. And it is the exact same use case to be able to build once and deploy anywhere, to use the same consistent architecture across the board. And finally, we'll deep dive into Athena Health, where Athena Health was trying to migrate their monolithic legacy application, and they broke it down into smaller chunks, and I'll walk you through the details of how they were able to accomplish the migration process. Now, whether the customer is looking to optimize TCO or looking for international expansion or regional expansion, like in the case of Epic, they want consistency across the board. And by consistency, I mean consistent security policies, consistent APIs, consistency in terms of availability. A lot of our customers start their migration journey with the AWS region, and they build cloud-native applications there, and then they look at applications that they can be migrated to a distributed hybrid sort of edge scenario. The other segment of customers, they start their migration process on premises. So instead of an outside-in sort of a scenario, they are looking at an inside-out scenario where they use migration acceleration program MAP or some of our flagships programs to migrate their workloads to the region or some of our other offerings like Outpost or local zones. So whether you choose an outside-in deployment model or inside-out, they always start with the AWS region. Today we have 102 availability zones across 32 geographic regions, and the regions offer the most amount of services. We have over 200 services. And how many of you are using an AWS region today? OK, few of you. And, but not all workloads can be migrated to the cloud. So a lot of customers that I talk to, the customers that I work with, they reach out to us when they get to a point, hey, I've migrated all these peripheral applications. Now, what do I do with this monolith? Or I have this latency-sensitive application. What do I do with this? Or I have this local data processing requirement. What do I do with this workload? So that's what we are going to be focusing on. The three set of use cases that we'll focus on today is one that is bound by data residency. My betting and gaming customers, like FanDuel, they have data residency requirements where they need to keep their customer data within state or sometimes even in a specific data center or in a building. I work with a lot of government agencies where they need to keep citizen data within country, while other customers have different data classification requirement where they can have a backup while keeping the golden copy in country or in state. So whatever the data residency data isolation requirement is, will work through a process where you can isolate the requirement and you can look at these workloads and devise a plan to migrate these workloads. Now, low latency. The gaming customers that I talked about, Epic, they have sub 10 millisecond latency requirement. Some of my other customers, they have microsecond latency requirement. I'm sure you've all heard of how we've partnered with NASDAQ to move their options exchange to the exchange variation of Outposts. So in these different scenarios, we work backwards from the customer requirements. What is the latency requirement? And you need to have a sub 10 millisecond latency across all of your application stack, or is it just connecting to the data layer, or is it just your front end? And we isolate those requirements, and based on that, we help them migrate to the region and other options like local zones, outpost servers, Snow, et cetera. We talked about local data processing requirements. One of my customers, they're working on a computer vision at the edge where they are unable to transfer data to the region and back, not just because of cost, but also because of data residency requirements. So they are using a smaller form factor of Outpost to run data processing at the edge, and then pass the information to the region when that's done. So we almost always run into a hybrid deployment model instead of just a singular, like, oh, I'm just going to use the AWS region, or I'm just going to use local zones, or I'm just going to use Outposts. Now, I talked about all of these offerings, so I'll walk you through how we at AWS are thinking of addressing these requirements in terms of how latency, data residency, data processing, or sometimes even a data isolation requirement or connectivity to a legacy mainframe database. AWS offers a continuum of consistent cloud services wherever you need it. As you can see, most of our customers, like you, start with the AWS region, and we have region in 102 availability zones. So most likely you have already embarked on a migration journey with the region, or maybe even more local zones, Outpost, and some of our products. So as they think about, some of the customers that I work with, as they think about migration, they start with the region, then they keep these workloads that they cannot move to the region. And when we do a workshop with them, or when we work backwards with them, we work on deployment strategies to move this. So one of the deployment strategies is to use local zones. And local zones offers compute, storage, and a certain set of targeted services closer to you and your end users. So local zones brings AWS clouds closer to metros and your end users. Today, we have local zones in 36 locations. Half of this is in the US, and half of this is across the globe. How many of you have used local zones or have evaluated local zones today? Great. So 2, 3. All right. So the way I think about local zones is as an extension of our AWS cloud. And local zones offers you the same elasticity, same scalability, same pay-as-you-go compute at the edge. So if you have a workload which may be spiky, or if you have a workload which is transient, local zones is a great fit for that. Now, as we started talking to our customers, a lot of them wanted to have a local zones type of deployment on premises. What that means is they wanted dedicated capacity, AWS managed, with the same scalability, with the same elasticity on premises. So we launched dedicated local zones in September. Dedicated local zones, you can work with AWS to deploy a capacity exclusive for you or a community of users that you support, while satisfying your IP-specific requirements or data residency requirements, or sometimes it may be low latency access to your fulfillment center or some other on-premises workloads. We do recommend that you need to have a minimum threshold to be able to qualify for dedicated local zones. If any of you are interested in learning more about dedicated local zones or setting up a DLZ, please come find me after the session, and I'll walk you through the process. Customers have to go through a configuration planning exercise where we look at what kind of services you are going to get, what security posture that you need, what compliance requirements do you need, what additional security, like for example, we have local personnel operating our the dedicated local zones. And we also make sure that if you need any kind of clearance, we make sure that the personnel has the clearance needed for that. We knew from very early on that not all workloads are going to be able to move to AWS region. And with that in mind, we launched Outpost a couple of years ago. How many of you have heard Outpost or are using Outpost today? OK, more than local zones. That's what I thought. Great. So Outpost brings a slice of the AWS cloud to your on-premises data center. Outpost offers a fully managed service on-premises where you don't have to worry about patching or anything. We offer compute, storage, and certain set of targeted services on-prem. And a lot of our customers use Outpost for the same requirements. Sometimes it is low latency. Sometimes it is data residency. Some of our customers use a combination of Outpost and local zones to satisfy these requirements. Or sometimes it is simply local data processing requirements. Outpost is available in 76 countries, 76 locations, and is available in the larger form factor, which is a 42U rack, as well as two smaller form factors, 1U and 2U. Again, if you want to learn more about these services, please come find me afterwards. I can talk to you about what services are available, what additional offerings are available on top of these Outposts, local zones, and some of our products. Now, you might ask, OK, I have the region which is where most of my workloads are bound. Then I have local zones, which is closer to me and my end users. And then I have Outposts that I can install in my on-premises data center. What about denied, disrupted, or intermittent connectivity use cases? For that, we have Snow family of use cases. The Snow family offers you a compute in different form factors, again, for denied, disrupted, or intermittent DDIL connectivity use cases. We have Snow in one of the most extreme scenarios in space. It's there on oil rigs. It's there on military deployment. So all the different DDIL use cases that we can think of. Snow is available in 20 of our 30 regions. And if you are interested in trying out Snow or Outposts It is available in our Outpost test labs in a couple of different locations, 3 locations in the US, 1 in UK, and 1 coming soon in Asia Pacific. So if you're interested in testing out any of these, come find me after. Now, I want to spend most of my time talking to you about different learnings and different experiences from all the customers that I've talked to. In the last 6 months, I've talked to more than 50 customers on this very specific topic of migration and how to migrate these use cases that are not easy to migrate to the AWS region. So I'll give you a couple of different strategies, 4 to be exact. The first one is to decompose the application into smaller chunks and take a phased approach. What that means is if you have a monolith, like in the case of Athena Health that we'll just get into in a bit, they had a Perl-based monolithic application, and the first one that they took care of was the peripheral application. So they migrated the peripheral application to the AWS region. Then they migrated application that needed low latency connectivity to Outpost, and then they optimized with local zones. Again, one of the customers that I talked to just this morning, a mining customer from Australia, they are using every single product from the portfolio. They're testing out every single product from the portfolio. And one of the cool use cases is to use Outpost servers for image recognition so that their plans are not damaged when some of these parts go through, to make sure they're consistent, they are now error-free. Mercado Libre, one of our other customers, has a similar use case where they're using Outpost servers for their robotics use case in their warehouse, where they want to make sure that they have a low latency access to place their merchandise in the segments that they want. So bottom line is to break it down in your monolithic application or your interconnected, if it is an interconnected application, break it down into smaller chunks and then set clear goals. What are the KPIs that you want? Is it a TCO optimization process? Or are you looking at sub-10 millisecond latency? Or do you need to do regular audits on our data residency requirements? Understand what your requirements, set those goals very on. Another key point that a lot of my customers miss from the very beginning is the skills gap. If your developers are switching between your monolithic application versus the AWS stack, it's a very difficult context switch. So make sure that you address that skill gap very early on. And one of the ways to do that is using the training program that is available through MAP, and I'll get to that in a bit. Now that you have broken down your application, the next step is to identify those workloads that has these special requirements. Do you have a workload that connects to a legacy database, like a mainframe database? Do you have any special data residency requirements for very specific use cases? Oftentimes, not all of your data needs to comply to these data residency requirements. It may be just citizen data that you need to have in your data center or in country or sometimes in state. So identify and document what are those use cases. Again, latency. Do you need sub-10 millisecond latency, or can you do away with 40 milliseconds of latency, or do you need microsecond latency? Understand the different requirements, document it. So step 1 is to decompose your application. Step 2 is to understand the requirements of each parts of your application. Step 3 is to see if what process is better for you. Do you need to rehost, or do you need to refactor? I'm not going to go through the 7 R's of application migration. We'll just focus on rehost, refactor, and retain. And specifically across rehost and refactor. So a lot of my customers pick rehost. Rehosting or lift and shift is simply the process of migrating your workloads as is without making any changes. If time to market is super important for you, this is the right process for you. You can get your applications to the cloud, cloudify it, and then use managed services like EKS or RDS on Outpost. For example, one of our customers, they were using native Kubernetes. They migrated self-managed Kubernetes to EKS. Again, a lot of our customers lift and shift first and then look at what are some of the ways that they can optimize for the AWS cloud and gain efficiency, optimize TCO, latency, and other requirements. The second option is to refactor, or retool, or replatform. A lot of customers pick this option. I know this is a little difficult compared to, a little harder compared to lift and shift. But a lot of my customers pick this option when they do not want to context switch between the two stacks, when agility is super important for them, when they want to maintain consistency from the get-go across the different stacks. And I'll walk through in a bit in terms of how you can use a strangler fig pattern to refactor code. Strangler fig pattern is essentially investing in building code in your new platform and ultimately retiring your legacy application. Athena Health used the exact same process, and I'll walk you through that in a bit. The great thing about this approach is the strangler fig pattern is that this can be incremental, and the changes are minimal, and the risk is minimal. So you can incrementally update your platform and move your applications incrementally, ultimately phasing off your monolith when you're confident that your applications can do what it's supposed to do. Finally, pick a distributed hybrid infrastructure. What that means is you just don't have to select Outpost, or just don't have to select local zones, or just don't have to select regions. You can select a mix of all three, or two, or whatever your application requirement is. So basically work backwards from your requirement to make sure that you are meeting all the reliance, performance, all the requirements. So before we get into Athena Health, just wanted to summarize the 4 strategies that I talked about. The first one is to decompose your application into smaller chunks and taking a phased approach, while also making sure that you have clear business goals. The second one is to identify requirements that, like latencies or data residency or other requirements, which limits you from using the AWS region. The third one is to pick an option. Is refactoring the best option for you, or do you need to just lift and shift and then migrate as you need? And finally, picking a distributed hybrid infrastructure. So Athena Health is a leading provider of network-enabled software and services for medical groups and health systems nationwide. They embarked on its journey when they hit scalability and reliability issues. They have a Perl-based on-premises deployment where they're using an Apache server and connecting to a legacy database. The outcome of this migration process was consistency, agility, not having to switch across different platforms, and they basically had set up a SaaS version of their core application where every single customer would get a full stack. So instead of doing that, they were able to provision faster, they were able to meet customer requirements faster, and they were also able to save costs in due process. So I mentioned some of the challenges that they had. So when they embarked on this journey, they started picking the applications that were on the periphery. They started modernizing applications that were not tightly coupled with their monolithic applications. And they moved those to the AWS region. And once they did that, they quickly realized that it was not easy to modernize their legacy Perl-based system. So they used a strangler fig pattern where they moved their front end to Outposts that would connect to their legacy database on premises. And they also had set up SNS and SQS event queuing to make sure that it talks to the legacy database and connects all of these applications in the region as well as on Outposts. So like I said, they started with Outpost, and they also made sure that the developer skills were aligned. Now, here's a reference architecture of where they landed in the intermediate. Eventually, they transitioned to a local zones plus Outpost-based model, but you can see that they have a monolith centrally deployed in their data center. They have 2 data centers, and they have 2 outposts per data center. It's very important to make sure that you have failover, redundancy, and HA built into your architecture. They were hosting their core application, so they've built in redundancy for that. Now, when they started on this migration journey, they quickly realized that the Outpost has limited capacity, and not all applications needed to be on the Outpost. So those ones that are not latency bound or not bound by any other constraint like CI/CD or logging, they moved that to the region. And they set up event queuing system to make sure that it talks to the legacy database on site as well as to the Outposts. So they prioritize Outposts for 2 things. One is microservices access to the database, and the second one is they started breaking down their Perl-based application, so migrating that over to Outposts first and optimizing it on the AWS stack. Eventually, once they optimized their stack on Outpost, they started using the Boston local zones to optimize for TCO. As you know, you can get on-demand self-service capacity on local zones. Not all workloads needed the same level of latency. For the workloads that didn't have any latency-specific requirements, they picked the AWS region. For the ones that had some kind of latency requirement but still could handle a little bit of latency, they picked local zones. And for the ones that absolutely needed to be tightly coupled, connected to their on-premises legacy database, they optimized it on the Outpost stack. And we're continuing to work with them to migrate their legacy database, and eventually they plan to migrate that over as well. Notice that they set up Direct Connect from Boston local zones to their data center. That means they have high-speed connectivity, and that way they were able to optimize their network as well. I want to take you through quickly through Absa Bank. It's a similar story where Absa Bank had a series of interconnected applications, and they saw an opportunity to migrate when their parent company sold Absa Bank. And they wanted to improve reliability, also wanted to develop a self-aware risk management analytics solution. The outcome of this process was 5% reduction in financial costs, satisfying their data residency requirements. Absa Bank operates in 12 African countries and serves around 9.7 million customers. So imagine the amount of customer data, especially citizen data, that they have to process every single day. So they started the migration process with the region. They migrated over 100 workloads to the CPT Cape Town region. And then, again, they hit a blocker with their analytics and other workloads which were bound by data residency requirements. So they picked Outpost, and they migrated some of their workloads to Outpost first. And these workloads are can intelligently place themselves based on their data residency requirement. That is super cool because not a lot of my customers have applications that can do that. Here's a quick snapshot of their reference architecture, and you can see that they have 2 different data centers, and DC1 and DC2, and they have 3 different outposts. They've built redundancy. They started with the applications that are low risk, migrated to the region. Then they picked the ones that had the data residency requirement. My team will be going through this reference architecture in detail on Thursday right here in MGM, and I will share the details of that chalk talk in just a bit. Similar to ABSA and Athena Health, they all followed the 4-step migration process. They broke down their monolith and their interconnected applications into simple ones. Then they looked at the requirements. Then they also saw, hey, is refactoring a better option for you, or is lift and shift a better option for me? And then finally, they picked a distributed hybrid infrastructure that included both outpost and local zones. Now, I wanted to invite Umar to go through network cloudification to talk about how some of our CSPs are working with us to migrate their core telco workloads. Thank you.
Thank you so much, Roshni. I hope you guys can hear me. Okay, great. So I'm going to talk about network cloudification, but not any network cloudification. Drum roll, 5G network cloudification. So my name is Umar Chaudhary. I'm responsible for the product management for telco workloads within the EC2 Edge team. And today I will take you through the specifics of 5G network functions, which are actually migrated into the cloud through this whole hybrid cloud journey. What are the challenges that the customers are currently facing? How we are providing a solution to overcome those challenges? And then we'll take you through a reference architecture as well as an example of a European customer, Telefónica Germany, who is embarking on this journey. So I'm sure that like most of you, if not all, are familiar with 5G network or 5G because you're using it on your phone. But how many of you are familiar with the 5G networks? Okay, so few. Okay, so now, before I go into the definition, a very crisp definition of 5G network functions, let me tell you one very important fact, which is that as the communication service providers, that is the AT&T, Verizon, Telefonicas, etc., of the Orange of the world, as they move their network functions into the cloud, their whole paradigm changes because now cloud becomes a COGS entry. It's a cost of goods sold. It is no longer an SG&A entry. And that is a very important aspect because it means that now it affects the product's bottom line that is being sold. So let's go through the definition. What are these network functions? So they can be widely, and there would be a lot of acronyms because telco loves acronyms, ABCDs and stuff, right? So I apologize in advance for that. However, I'll try to abstract that complexity out. So the first one is the radio access network. Very simply, it is the last mile as it goes through a radio interface into your cell phones, right? Primarily, it is comprised in 5G. It is comprised of 3 major components. One is called the radio unit. One is called the distributed unit, which is still on site, on the cell sites. And the other is called a centralized unit to implement a cloud RAN kind of a topology. So that is one very important part of it. And now you think about a magnitude, you're looking at like hundreds and thousands of sites that an operator would have, like let's say an operator of the size of AT&T or Verizon. The second one is a packet core network. And the packet core network, the way you actually browse data and you consume data on your cell phone, that goes through the packet network, packet core network. And it is comprised of 3 major functions. One is called the control plane function, so how the sessions are managed. The other is called the subscriber management function. It means how the subscriber data is being managed. And the third is called the user plane function, which essentially means that how the data throughput is being managed, how you are getting the payload. And then the last one is which we call IMS or IP multimedia subsystem. That essentially means your voice or the text or multimedia over IP, right? So voice over IP. So that's the broader definition. Now let's look at what is the current predominant deployment model before I go into the problems that we are trying to solve. So for the radio access network, primarily you're looking at a single stack solution. It means one ISP provides a complete stack, which would be hardware and software. Yes, it can be very efficient. However, it lacks the flexibility. So it means that the customers, which are the CSPs, do not get the flexibility of choosing and mixing and matching and getting the best out of the technologies. When you talk about the packet core networks, they are a little bit further ahead in their virtualization, cloudification journey. So they have while there are vertical stacks, there have also been cloud stacks on private cloud stacks based on OpenStack technology, using Red Hat OpenShift, using VMware. However, one word that you will remember here is the complexity, because they are still very, very complex to manage, deploy, and then operate. And then for the IMS systems, they're mostly legacy monolithic systems with a single stack appliance-based solution, because most of the CSPs do not make huge amount of money off the VoIP traffic, right? This is an essential necessity that the operators have to manage. So let's go into now some of the challenges that current deployments bring. And of course, like as 5G is rolled out, it is further comes into play. So the first thing is the mission criticality. That means that these are huge networks. They are nationwide footprints, which essentially leads to a high available system. But then as private clouds are implemented, they become extremely difficult and complex to manage. You're looking at like 20 plus, 30 plus different ISPs applications which are making up of this network. So that's the complexity is the really big challenge. The second challenge is these are distributed in nature, because in order to get the best speeds, in order to get the 5G speeds, in order to get the best downloads and stuff, you need to have the systems as close to the edge as possible. It means that now they are being distributed to not only 2-3 data centers, but like maybe 20s or 30s or 50s of smaller sites. So latency is a big challenge. Then comes the third one is, if there is one variable which is constant in this whole, which is known in this whole 5G journey, is that the data consumption is going to increase. Now, new use cases are coming. The consumers are increasing their pattern. I was talking to a customer in Asia Pacific a couple of weeks ago, and they told me that 75% of their traffic is TikTok, and it's constantly on the rise. So, but what does it mean? It means that now, think of the user plane function. The customers have to continuously invest in more infrastructure to build the capacity. So building of capacity and then managing that capacity is a very, very high intensive job. It requires a lot of system integration. The time to market gets worse. Then the last one is that they are highly regulated industries. It means that like there are regulatory aspects and the security aspect that need to be considered. Now let's look at our solution, AWS solution. And that flows very much into all the components that Roshni has just described. The number one and the fundamental part is cloud continuum. But what does it mean in terms of the network functions, in the network workloads? What it means is that like now the network workloads can run where they are supposed to run in the most efficient manner, both in costs as well as performance. So it means now the non-latency control plane network functions can be in the region. The latency sensitive ones can be on the local zones. And the ones which require low latency can be on the outpost. So cloud continuum is really the basis of our solution, which leads to that how are we able to extend the cloud? It's the sameness, which means that like the same EC2 instances, the same APIs, the same CloudWatch, the same Kubernetes managed service of EKS and ECS. We are basically extending it throughout the cloud continuum. That sameness, what does it give us? It gives us a uniform architecture. And uniform architecture, think of it this way. A customer deploys these network functions. If an ISV has to have one build of application for on-prem, one for local zones, and one for region, there's no sameness. It means that like the scale out cannot be done. So what we are providing is, by providing the same services, the customers do not have to worry about that there would be different application builds. And that is a very fundamental part of it. Then the way we provide it is as a managed service, whether it's a managed service in the regions or local zones or outposts, or it's the managed services like EKS and others. So the heavy lifting from the customer is minimized. And last, which is extremely important, is that everything was, up till now, was building the networks. But how do you operate them? How do you bring that automation that is inbuilt in the AWS cloud because of the size that we need to operate in? We bring that cloud automation to the telco customer as well. So that is really what our solution is. Now let's quantify that in terms of core and RAN workloads. I'll go through this quickly. However, think of it this way. First is the TCO benefits. So there are two components of it. One is that like the network functions are running in the most cost-efficient manner where they're supposed to run. So it means that like that is one aspect. The other aspect is that all the new innovations that we have, let's say in our own silicon of Graviton, which is cost and power efficient, we are bringing those as well. And then in one study, we have come up with like it was almost 50% more cheaper in terms of the TCO benefits. Then comes the automation and productivity. That essentially means that like with the cloud continuum, right, there is reduction in OpEx. So the IT teams can be used for the network management as well, and vice versa. So there are less teams which get involved in it. And of course, like with some of the services that we are bringing in, like Telecom Network Builder, which automates the deployment, that adds to the efficiency and the productivity. Then comes the operational resilience, which essentially means that now Roshni had described that a region comprises of multiple availability zones, 2 or more, 3 or more, which comprises of each availability zone is comprised of 1 or 2 or more data centers. That essentially means that by inherent nature, there is more high availability. And that actually gets translated. And then the last but not least is essentially the time to market, that the business agility, with all of these things being managed and seamless, the customers are able to bring the services quicker to the market. Let's quickly go through the RAN on AWS as well. And here, think of it like a slightly different approach. So the different approach is just a reverse order. And the biggest problem in the RAN is there are thousands of sites to be deployed. If they cannot be deployed automatically using automation tools and subsequently managed, your cost would be huge and your time to market would be huge. That is a very important thing. Then the operational simplicity is exactly the same. Now your core is on AWS using the same automation tools, and the RAN would be on AWS. That gives you that breadth. Then operational resiliency is in a very similar manner as well. I'll give you an example. In the RAN, you have as I said, there are 3 systems, right? So the centralized unit is something which all of the DUs combine in, or some of the DUs combine in. They can be actually centralized in the local zone. So that operational efficiency is a factor of that as well. And then the last is the performance and TCO benefit. Excuse me. For that one, essentially what we are looking at is that at a cell site, the power is a very, very important commodity, because your power is what drives the cost up there. You have to put dedicated power there. By putting like Graviton-based servers, which we are currently working on with some of the ISVs, we essentially are trying to reduce that power cost there as well. And that is one way of basically improving the TCO benefits. Now let me just paint you a picture of like, so here's the building blocks, the regions, then you look at the metro center and local zones. So can somebody tell me that like, what is one of the biggest workload in the local zones? So we actually built AWS US local zones to host the UPF and the VCU workloads. That was one of the first and the biggest workload. Of course, like the local zones are public, and then there are other workloads which come in as well. That means that like local zones is a very integral part of it, because think of the metro centers, right? In Vegas or in San Francisco or in other places, in the metro center for the latency, we can provide the latency through the local zone that is needed for the UPF workload and the VCU workload. And then comes the AWS wavelength zone, which essentially is now a partnership, which is partnership play with the CSPs regarding the MEC. And then of course the Outpost and the Snow family. But how does it now really mesh into the telco networks? And that's where I said that like there are a lot of acronyms for it, but think of it this way. All of the control plane functions are on the left or on the left-hand side, which is the regions. All of the user plane functions, latency sensitive functions, are in the local zones. And the distributed nature of it, the UPF as it gets distributed, is on the Outpost and further to the sites. So that is how generally like you can call it a perfect reference architecture. So in a geography where you have regions, local zone, and outpost, you can pretty much cover the complete geography. Now let me give you one example of Telefonica Germany and the very specific problem that they are solving. So it's Telefonica Germany serves more than 44 million customers, for both consumers as well as enterprises. And when they started implementing the 5G, and specifically 5G core standalone, then they started to realize that they want to change the way a monolithic network is built and operated so that they can bring the services much faster to the market. And that's where we worked with them, and I'll show you the architecture in a minute. We worked with them and built an architecture, and the network functions are deployed using the regions as well as outposts. So it is distributed as well as in the control plane is in the region. And where they really got the benefit out of it is to get the services much more faster, because now the order management, the order fulfillment, and the service fulfillment is like completely integrated into the cloud. So that was the fundamental part of it. Now, this is how it comes together for a customer. So if you look at it, in the region, in this particular case of Telefonica Germany, in the European region, we have the control plane function, which is called SMF, which is called session management function. So all the cell phone sessions are managed through that. That is in the region. However, I spoke about the resiliency and the high availability. It's a multi-AZ, multi-region deployment. It means that the high availability is much higher. So you can see that. And now the user plane functions are distributed across the country on outpost sites, and these user plane functions are called UPF. One very important point which I did not mention, which I would like to mention here, is just one second. There. If you look at that box at the top, so while we also do realize that all of these network functions have very specific requirements. They have very high throughput requirements. They have specific networking requirements. So as AWS, we are investing in building the EC2 networking features, as well as some of the other features and services that are needed to run these network functions. So that is the reason that there is a very coordinated effort in the whole network cloudification. Okay, so I will now ask Roshni to show you how to actually go through this journey of hybrid migration. Thank you.
Thank you, Umar. I'll try to quickly wrap up so that you have plenty of time for Q&A. So getting started with migration, how many of you are familiar with our Migration Acceleration Program? Wow, I thought a lot more would be. Migration Acceleration Program is basically all of our learnings from past 12 plus years, helping customers migrate to the AWS regions and different AWS products packaged into a single program. What that means is it's not just, if you've used MAP, it's not just about credits. And we also offer you training through the AWS training program. We also offer you tools in-house as well as through partners. We also offer ProServe as well as a partner help to get you on this migration journey. And this is done in 3 phases. The assess, mobilize, and migrate and modernize. Assess is when me and my team come to customers like you and go through your workloads. We do a migration assessment, look at all the requirements, we look at all the specifications, we run workshops, we work through all of the skills gap, and mobilize is where we build the early muscle. We built repeatable process in Mobilize, which we can scale in Migrate and Modernize. So across these 3 phases, we offer you a comprehensive framework to look at migration as a whole. And this is applicable to any industry, any vertical, or any customer. With that, I will wrap up with the 4 key strategies. If I want you to take away one thing, it is this 4 different strategies we talked about. The first one is to break your application down into smaller chunks and make sure to take a phased approach while not losing sight of your KPIs and goals. The second strategy is to look at all the individual components and see if you have any specific requirements. The third strategy is to see if rehosting is better, refactoring, replatforming, whatever is better for you. Finally, use a distributed hybrid infrastructure. If you want to learn more about and dive deeper into migration and look at specific reference architecture and other real-life examples, I recommend that you attend Hybrid 313, where my team will go through real-world assessment of other customer examples. Thank you all for joining us today. Please make sure to fill the survey. It's very important for us to understand what's worked and what doesn't and how to improve. Thank you for joining us today.